Today we're going to review linear equations. Most of you have learned about these in Algebra 1. If anything like y equals mx plus b or lines, slope-intercept, any of those words sound familiar to you, that's basically what we're going to relearn today. I want to start by defining a linear equation. Basically, a linear equation, it's just a formula that you develop based on a pattern. And then what you can do is you can actually plot points that are occurring in that formula and then use what you have to make a prediction about the future. So if you ever want to pursue a degree in business, per se, you learn to use these forms and we call them business models. So it is an important concept to understand. You guys have been probably familiar with slope-intercept and standard form. Slope-intercept is just y equals mx plus b, and that's what most of you have worked with in the past. Whereas standard form is what you see before there, ax plus by equals c. The rule is a, b, and c have to be whole numbers. They can't be fractions or decimals. They have to be whole, and you want your x's and y's on the same side. We don't really use standard form for a lot of things, but we do use slope-intercept form. If you are planning to go into like trigonometry or advanced algebra 2 or anything like that, you'll see standard form more there than you will in geometry. So for slope-intercept form, the two letters that matter are your b and your m because they control your pattern. B is your y-intercept, or in other words, it's where you start. So if I wanted to plot a line, let's say this is my line. This is your b, this is your y-intercept, and that indicates where the line, basically what's the first point that we put on our graph, and from there we can make a pattern. And then m is going to stand for your slope, and that basically is a comparison of height to length. So each time if our line, let's say, is going down 3 spaces and over 2, our slope is -3/2. So another word we use for that is rate of change. It's a measurement of rate of how much things are changing over time. So in this case, our y-intercept is 0, 3. Those are the coordinates for where our line crosses the y-axis. And our x-intercept would be 4, 0, because that's where it crosses the x-axis. So we call those our intercepts. And what you should realize is for every intercept, the opposite letter is going to be 0. So for the y-intercept, x is 0, and for the x-intercept, y is 0. So if you were ever asked to find, say, an x-intercept, you would have to plug 0 in for y, or substitute that in for y, and get your answer. And if I would like to count the slope on this, I pick 2 points that are on the graph. So I just picked these 2 because they're already there. And it looks like I'm going to have to go down 1, 2, 3. So my change in height is 3. And I'm going to go over 1, 2, 3, 4. So my comparison, my change in height over change in run is 3/4. Now since our line is going downhill from left to right, I know that it's going to be a -3/4. It's a negative slope. So what I want to talk about, there always seems to be some confusion with slope with high school kids. So very easy way, you don't even need to worry about the signs of anything when you're counting. Just remember, if a line goes up from left to right, it's a positive slope because it's increasing, kind of like you're going up a ski lift. If your line is going downwards, it's going to be a negative slope because you're coming down the ski lift, or not down the ski lift, down the ski slope. So use that as if you're stuck on, well, where should I put a negative sign? When you're counting slope, just throw it in at the end, okay? Graph your line, look at it, and then decide if it's negative or positive slope. So what you have to do for homework tonight is basically solve for y, and that means putting it in slope-intercept form. If you notice, y equals mx plus b, notice that y is all by itself. That's what we want. Once we know we have y by itself, we know our honest slope and our honest y-intercept, and that is enough information to graph the line or graph the pattern. So to get y by itself, I need to first subtract 2x from both sides. Now, I'm not going to do 14 minus 2 because they're not like terms. So what I do is I leave my x's out in the front and I tack my number on the back. Now, y is still not alone. I got to get rid of the 3. So in order to do that, I have to divide everything in the equation by 3. Leaving me with y equals negative 2/3 x plus 14 over 3. And you guys are more than welcome to leave your answers as fractions. The only time I might turn this into a decimal is if I was asked to graph it, because that's a little bit easier to understand. But fractions are fine, just make sure they're always reduced. So my y-intercept, I can easily see it now, is 14/3, and my slope is negative 2/3. What we're going to do is we're actually going to take an equation and we're going to graph it on a coordinate plane, kind of review that. So you always start with your second number, the one that does not have an x beside it, and you're going to go up 2 spaces. All right, you always plot on the y-axis first, never on the x-axis first. And since it's positive, I went up. If it said minus 2, I would go down. From that point, since my slope is 3/4, I'm going to go up 3 spaces. So 1, 2, 3, and over 4. 1, 2, 3, 4. And I know that I went the right directions because I went up 3 over 4. It's a positive slope, so my line should go uphill when I connect it. Now in the second example, I'm actually starting at negative 4. So I got to start down 4. If you look at your slope, it's negative. So your line should be going downhill. That means you can either go up and to the left, or you can go down and to the right. Again, because your line needs to go downhill since it's a negative slope. Since 3 is not a fraction, I'm going to very easily make it a fraction by putting it over 1. So you can always put something over 1 if you don't have a fraction. And I'm going to go down 3 and over 1 space. And up 3 and over 1. So no matter how you do it, you're going to have the same line that I have. In these examples, we actually need to solve for y first. Notice y is not by itself, so it's not ready to graph yet. So we're going to go ahead and solve for y, and then we're going to graph it in slope-intercept form. So you end up getting y equals negative 2x plus 4. I'm just going to change that to 2 over 1 just so it's a fraction. And we're going to go up 4. And since my slope is negative, I'm going to go down 2 into the right 1 and connect. Now try example 4. When I graph this line, I'm going to start down 2 since it's negative, and I'm going to go up 1 and over 2. So you always go up or down, whatever your top number is, and you go over whatever the bottom is. Okay, so in order to write equations of lines, and that again means in order to tell me a pattern, so in that formula you need to tell me what n and d are. In order to achieve that goal, you can have either 2 points, so I would have to give you 2 separate coordinates, or I can give you a point, 1 point, and the slope. But you need that information in order to write an equation of a line. So this should look familiar to you. This is your slope formula. You basically subtract your y coordinates, and you subtract your x coordinates, and you write your answer as a fraction, a reduced fraction, that is. So for the first example, we're just going to find the slope, okay? We're not going to write the whole equation. I still label my coordinates x1, y1, x2, y2. That should look familiar from what we did way back in chapter 1 with the distance formula. And when I substitute these values into my slope formula, I'm going to be really careful about my negative signs. I'm going to do -6 minus, and instead of y1, I'm going to plug in -1. Notice that I'm writing my minuses side by side like that. So this actually becomes -6 plus 1, which is -5. And -3 minus 5 is -8. And do me a favor, anytime you have 2 negatives being divided, it's going to be a positive outcome, so rewrite it as a positive slope. Now we're going to go all the way, and we're going to write an equation of a line using the 2 different types of problems you have. So in this case, I give you a slope and a point. In the other example, I just give you 2 points and no slope. So in this first example, since I know the slope is -3, and they've given me one x and y coordinate on this line I'm supposed to write the equation of, I'm going to go ahead and set up my formula. Y equals mx plus b. Now I know my slope. I know an x and a y coordinate, however, I don't know b. And when you write an equation, you only need to include the m and the b. I need numbers for those. So we're going to have to use this given information to figure out our b. So I'm going to plug 2 in for y. I'm going to plug -3 in for m. And I'm going to plug 4 in for x. If I do a little bit of simplifying, I'm going to find out that b equals 14. So that's great. We now know what b is. However, we're still not done because you were told to write the equation of a line. So we're going to use our y and our x again, but we're going to use -3 as our slope, and our starting point, or our y-intercept, is 14. Notice that anytime you write an equation, you're actually leaving variables in here. And the reason why is because this is, again, a pattern. So depending on what you substitute for x is going to control what you get for y. 4 and 2 happen to be a pair of points that work, that make this equation true, but there's more than one equation or more than one solution to this. There's an infinite amount. So you want to leave y and x in your answer always. Example number 3, this time says only 2 points. So your first step is to get your slope. Then we're going to substitute our slope and a coordinate into y equals mx plus b. Then we're going to solve for b. And our last step is to write our equation. Write your final equation. So step 1, here we go. We're going to find our slope using the slope formula. So 3 minus 5 over 4 minus negative 2. We're going to get negative 2 over 6. I am going to reduce that to negative 1/3. Step 2, I'm going to substitute my slope and one of my coordinates in for y, m, and x in order to figure out my b. So I'm going to choose to use 3 and 4 as my points. I'm going to get negative 4/3 here when I multiply. That is the same thing as negative 1 and 1/3. So I'm just going to write my answer like a mixed number. I'm going to add 1 and 1/3 to both sides, and I'm going to get 4 and 1/3 for my b. So my final equation is going to be y equals negative 1/3 x plus 4 and 1/3.